Okay. In today's session, we discuss about the number of ways to create thread. Yesterday, we discussed the theoretical part about threads and what is thread and the life cycle of threads. Right? There are different life cycles of threads. One is new state, then runnable, running, terminated, and dead. So we have a detailed explanation on that. Okay. Once again, we'll recap that. Say when the thread is created for the first time, means before your start method call that one. That is called a new state. We call it as a born state, thread born state. And when it comes to runnable, the moment you start method of thread, then it says runnable. But internally, when you call the start method, there is a run method automatically called by the JVM. When that run method is called, if the processors are available to run that particular thread, then the JVM will call the run method to execute your actual start. In that case, your thread state change from runnable to running mode. In this state, where actually your logic execution is going on. So this is a running state is the actual place where our task execution will happen. Once the task execution is happened successfully, then the thread state change to terminated, means it's completed his task, right? Due to reason, if you want to stop the thread, then you can change from running to again runnable state. As we seen this number of methods, right? Even the thread may go to a dead state also, right? If you were depending on the methods, right? The sleep method and pause the thread means suspending the thread, right? Like this, right? Depending on the scenarios, we have to go that methods, right? So the thread goes loose all these 5 life cycle states. So this is all about this life cycle of threads. Today we see that ways of creating threads. First approach is that extending the thread object. Sorry, extending thread class. Now let's have your class now which extend the thread, which means then you are acquiring, you are getting the thread functionality in your class. Extending the thread means then it is an inheritance concept, means you are acquiring all the functionality of the thread. You see that internally this thread class implement the runnable interface, which having only one method, run method, abstract class, abstract method, and this is a functional interface. So we can get all this functionality your class which extend the thread class. Now, what is the use of just extending thread class and how do we call this run method is that, so let's have right anyway, right? When, why do I say only run method? You can ask a question. Say we have a run method, right? Just now we're saying that there is a run method. We are overriding the run method here in your current class because you want to call that method here. In that you are providing a implementation to that, right? Run method is the abstract method, right? So you have to provide the implementation. The moment we call that run method means then it has to run that your code. So all our logic, all our code execution has is happened in this run method. That is what we are providing implementation to run method. Let's see now. I have a main class here. How do you call this? Multi-threading, right? Now I'm creating a multiple threads here to run this call method. Okay, let's see now. If I don't have a multiple threads, what happens when you just say forget about this for loop and just go ahead with this. Now I created a object for this class. So when you create an object for this class, then you have to pass that object to thread class. Then the thread class will take an object of this. What happens is then it is a target where it has to run, means runnable as. Then when you run this method, start method, what happens, right? The thread dot start method call this synchronized. These all synchronized calls. If you have a number of start method, right, it make all calls as synchronized. Okay, then when this call, then this guy gets called. You could see this one and during debugging we will see that how it goes. When I run this one, right, debug as a Java application, you could see the first time it comes here and then this guy gets called. Now, how many times you are invoking this thread? This case only once. That way you could say thread 1 is currently running. Now, if you want to submit multiple tasks, so that only run method will be helpful. You don't need to have multiple run methods. One run method take care of this one. So how you do that? Now let's revert back this code and assume you are submitting 5 tasks to the current thread. So you can have this for loop like that. In real time scenario, this data can be anything. Instead of fire, it can have a number of threads. Also depend on the user request. Means every user request, a separate thread will be created and running its own path of execution. Now let's see this. This time, how many times it gets called? Now it comes here. Now this guy gets start. When this gets start, right? See, let's keep calling this one, right? See, now 5 times, and this guy is keep calling 5 times. It is not, and it is the moment we call, the request comes here. Means this, the start method is called, so it will be invoked later also. I mean, just 2 to 3 seconds also, when right, because the moment it starts, right, then it just delegate the request to the JVM. Hey guy, I am starting the thread, and with the start method, you have to call the run method. It is your job. So the JVM look at that if the processors are available and the space is available to run this thread jobs, right, then it will automatically run that. If no processor available, then all the requests will be in the blocking queue, and once the processor are free, then the run method gets called. Now without debugging, you see this. Now you could see how it is happening. 1 3 1 5 7 9 11. These are the thread names. You could see what we are printing, the currently running thread names. It's a name, right? The number of threads it is creating. You could see now 1 3 7 5 9. Ordering of the thread also is not guaranteed. Every time it is getting different order. You see this one, right? 1 11 9 7 5 3. Next time when you run, and order they keep changing that. So there is no guarantee that the threads are creating that. But however, it create a each separate thread for every user request. That is sure that. Oh, so this is how we can achieve by extending the thread. Here you can have a number of methods also, right? See, thread dot current running thread, right? What you can do, you get the ID of the thread and what is the priority of the thread. You can set max priority, right? Is active count, right? All these methods you can do that. Is it a demand thread? Is thread alive? That if thread is still alive or not. Means if the thread is dead, means then you have to start the thread again. So it is interrupted, check access, you have access to that thread. And so I told, right, if you want to join that another thread, means you want to invoke other thread, then join method will come. But how many milliseconds it has to wait before join? Then you have to provide millisecond. And notify, as we seen yesterday, right? We discussed yesterday. Notify is when the current running thread completes, finish its execution, then it notify, it wake up, means it wake up a only single thread that is waiting on the objects monitor. Means someone is executing in the object monitor, and who is waiting outside, right, has to be inside. Which means if any threads that are waiting on this object, means currently we are running this code on the object only, right? So to awake that thread, the choice is that you have to invoke the notify method. A thread waits that on the object monitor will be invoked, means will be activate to running that once this guy comes out. So see this notify all means it wakes up all the threads that are waiting on the object's monitor. So it doesn't look that, right, how many threads are waking. It just say notify all. Notify all means how many threads are there in the queue, right? How many threads are waiting on the object monitor. Every thread gets wake up. But which thread enters into the monitor is depending on the thread priority. If the thread priority is too high, then it will enter. How you could consider this? The priority number is starts with 1 1 2 3. The lower digit will give the higher priority, right? It is like a ranking numbers, right? 1 means the highest rank, like that. If the thread have the lowest numbers, then the priority is high. So this is how we can use the extending of threads. Now there is another way we seen that implementing the runnable interface. What is that implementing runnable interface means? You just have to implementers. Let's say class that implements runnable methods. This time we are not going to create any thread, extend a thread. We are directly utilizing the run method. So here I have implemented the run method, same here, but I have written some logic here to understand in more detail. That's what's happening here when you start and what is it is doing. Now this time I'm not going with the for loop here and this, and just I'm creating a two threads, right? One is employee thread and another is customer thread. Let's say that what happens in when you create object to this, right? First you have to start. Basically it should not be start that. First you have to send this object to thread method to call this search value. This I have written a separate method to start this method. When you start this one, right, where it goes, this guy comes here. Now you have the thread null, because the moment you start the thread, right, then it will not call the start method. This start method is a custom method, right? We are not calling the start method of the thread, right? So when you say start method of the thread, then only actual run method gets called. Otherwise it will not happen. Let's say now I remove this one. Okay, for example, now I commented this. Okay, now say run this program and see what happens here. Okay, put up this here in a separate method. Okay, created employee, just starting now, employee created customer starting now. But you see this one, where is this starting thread, and there's this one created in the first time. The constructor is called because this is the constructor created employee, and starting now, what is that starting now is the start method of the custom method. But you see this one, the run method is not called. Why? If the run method will not just call like that, because you have to call the start method of the thread. Then only the thread knows there is a run method which I need to call. If somebody is invoked, then only I will move forward. Then only I run my methods that are associated to threads. That otherwise, say if you don't start the thread, then who will run this thread run method? So that is the problem. That is what we discussed, that if you start the run method of the thread, sorry, if you start the start method of the thread, if you call the start method of the thread will automatically call the run method internally. As told you, right, the JVM will take care of. Now you see this time you just run this one. See, now this time you could see now actual run method gets called and it's created the objects of this thread. So this is how internally this run method is wired with the JVM. The moment you call the run method, start method of this thread object, right, then only this run method gets invoked. Otherwise the run method does not know how to call it. It will not run on its own, right? To run this method, right, somewhere if you think about the normal interfaces also, right, if you do not call that method, right, it will not be invoked, right? That is the reason. It is like a method inside a method. This run method also inside of the start method of thread. So that is the reason when you call the start method of the thread, then the run method gets invoked. Now you could say this, we have used sleep of 50 milliseconds. So every time when you say 50 milliseconds, right, it is giving chance to another thread. For example, if I change to 1000 milliseconds, let's see what is the difference of this. See, now it is giving a chance to other thread, so that your threads continuously running one by one. Means if you sleep the thread, some wait for some milliseconds, means then this time it is giving a chance to other thread to enter into this and create executing is performing task. But let's see other scenario. If I don't give any milliseconds, okay, it is giving error because we don't have an exception code, right? We just say declared as some other exception instead of interrupt exception. Because if you go with the specific exception, then it says that that type of exception is not there, possibility is not there in your block of code. See now, you see this how it is happened. right? There is no order here. First, this employee is created to objects, then customer is created to, then employee is created all the four, then customer is created all the four. Hence, in this order of the execution is not proper. Again, you run this program and you see the order is keep changing. That you see even all the employees are created first, and then only it is giving chance to customer. Again, you see this one. I run this again and see this. Right. So this is how the different. If you make the thread to sleep for a specified number of milliseconds, the current thread will go to sleep for 1 second. In that 1 second, if any other request come to the same thread, then it give chance to that current thread to enter into that method. So this is how one of the place where we use that sleep method. Means it let you cause the current running thread for 1 second. When you are sleeping the thread for 1 second, then other thread which is entering into that object monitor will go and perform its task. So when it performs task, then 1 second will be completed for the current thread, and again it do its job. So the second thread, which is for 1 second, that again it's completed, time is lapsed, so it automatically enter into this one. So this way we can give option to multiple threads execution, say one by one. So we can do, but that's not only the standard way. We have many ways we can depend on the condition, right? As we discussed, to suspend the current thread and when to resume and all these things. Now you see this time every thread have a chance to create, means all the threads are running sequentially. So this is how we can create an object with runnable interface and thread. But you see this one here, this runnable method during runnable, right before your job gets started, you can explicitly pass the name of the thread. If you don't want that thread name to be customized, then you don't need to pass this one. In the earlier example, we see this, it is by default it is printing the name of the thread, right, which is from the thread.current thread object. But here we are explicitly given what type of thread this thread belongs to, which class. So to identify that this thread is for customer and this set for employee, like that. You can give your own names to identify the threads easily. So like that we can play around with all the methods that are available for runnable and the thread class. But make sure that when you are creating or working with the thread concept, right, you have to be careful that so how you are giving access to threads. So we have to make sure the thread should be synchronized and the code should be reliable, and make sure that no thread goes into the block state. If one thread goes to the block state, right, the remaining threads which are waiting at the object pointer will also get blocked. Then completely your program execution stop working until again you release the threads. Again you have to go and kill the threads explicitly, otherwise it will not release. So you have to be careful in such codes. But you see that when we have option to create threads using two different ways, but here we still have disadvantages. What is the disadvantage here? You see this now. Now this case I have created 5 threads here, means max 6 threads here, less than equals 5 means 6 threads. But in real time scenario, if you see then some hundreds, millions, thousands of requests are coming to the application. But how the operating system will handle that? So then creating the number of threads is depending on the operating system, right? Because every operating system has some fixed number of processors available. It cannot have, it cannot expand that process automatically, right? Each operating system comes with the minimum capacity, depend on the size of this operating system, right? Minimum capacity is a processors, how many processors are available. If user is requesting more request, right, then available process is less than the current request, then that time your request will not be served, means you will get stack flow exception, means the number of threads are exceeded than the available process. So how you do handle that one? Using the traditional approach of this type of threads will not help you, which means then we have to restrict that number of threads creating, right, because they are applying some algorithm, some design patterns, so that makes very complicated. Then to achieve this job in Java 1.5, we have a concept called executor framework. What is that executor framework? It will help you to create the fixed number of threads. Means it create a pool of threads. There we have n number of methods to work on this executor service is come into picture. This executor framework is nothing but that's we have n number of built-in methods built in. That executor service is the Java API. It is one of the API framework to enable multi-threading programming. How it works? It internally uses a blocking queue to store task event to it and execute them on the thread pool, which means that if we have if we create a fixed number of threads, and if the more number of requests comes, then it will not let you to create a separate thread for each request. Instead, it maintain a pool of threads, right? And it store all the requests in the blocking queue. Means it is store all the incoming requests in the queue. So when the threads are keep running, that it checks that which request comes first, then it will serve that request. It is like first in first out, because queue is nothing but the first in first out. That behavior is that. So this is one of the most common form to start new task on the different thread, right? So executor service actually a blocking queue only with threads attached to it, right? Threads that are attached to the blocking queue will be taking the task from the queue and automatically execute them. You don't need to say that this task is first and you have to pick that. Basically the threads are the consumers of the queue, right? So and you will be submitting tasks to the queue for the consumers to consume. Okay, now let's see that how it will be helpful, then how you create this task. Okay, let's create a simple class called class. What we can name this Java executor framework. Okay, put the main method also. Now, what is the first step? As we are talking executor service, right? Executor framework. So it starts with executor service. See this one. It comes from the package. You have see executor is there java.hotel.concurrent, right? Say this executor completion service, executors and executor service and executor, right? All these are from java.hotel.concurrent package. Just create executor service for this. So now, as we said, we have the option, flexible option to create fixed number of threads. So to fix a number of threads means we have to create an object. That see that sorry, we have to be in the executors. So it forms the okay. See this executor is the factory where you have all the methods that are available. See that's executor dot. You could see this new cast thread pool, no cast thread pool factory, new fixed thread pool count, and fixed thread pool a single thread executor, right? That's like that you have a number of factors are there. So you can go with that anyone depending on your requirement. Now let's go with the fixed thread pool. This fixed thread pool, say it takes the one argument as integer. Now if you say I said 2, then I am creating a thread pool of size 2. No matter how many requests come to your application, only 2 threads will be created here, because you don't want that. As we know that our use case is that we need to have only 2 threads that need to create to perform all these tasks, because you know that our application load is not too high. It's not expecting more than 2 threads. So 2 threads can do this job. Okay, now let's submit this task. Int I equals to 0. Now we take more threads than the initial size. I less than 5. Next I plus plus. Okay, what do you do then? Using executor service, right? We call that method. What is it actually? Executor service. If you look at this, this is an interface which extend the executor, right? We have to provide implementation of that, right? So executor service have the execute method. Now executor service dot, what do we say? That execute method execute. Here actually you have to submit the task. Means we are instructing, hey guy, please execute this job. What job you have to pass? You can have to pass. You can pass even any method, any class also. What class you can say? We will create one class here. Okay, new class will create runnable task. Okay, right now to see the simple runnable task. So here we'll implement the runnable interface. Okay, now we know that once you implement a runnable interface, you must have to provide implementation to that. So that is the reason it is giving the error. So here you provide your implementation. Let's now I'm giving only sys out. Currently running thread. I just print the name of the thread. Thread dot current thread dot. Okay, we print the name of the thread. Get name is there. Okay, we are done with this. So this job I will submit to this one. This creating the job instance, we have to create an object to this. Say what is that object? It is a runnable task. It is not available. Okay, now I have submitted this job. But now when we start the executor, right, this executor service will not automatically shut down, right? This thread will be allowed if you want to shut down that, because if it is one time, once this task is completed and you show that no more threads to execute, then you can shut down this. How do that? In the executor service we have a method called shutdown. You click this one. There are three methods available. Shutdown now is shutdown. What is the difference of these three methods? Shutdown means it shut down once the task is completed. Before the task gets completed, it will not let you shut down. If any pending task is there for you, it will complete those pending tasks and this shutdown will happen. Means it will terminate that thread. Shut down now, it is it attempts to stop all the activity completely. Threads means all active execute tasks. Means it, if any incomplete tasks that are waiting, right, it will not execute that one, right? It will just stop everything and say graceful shutdown. And this is for check method to return whether that thread is shut down or not. It is a boolean value. If the thread is not shut down, then it is a false. If it is shut down, true. Now let's use this one, shutdown, and say that service shut down successfully. Now let's run this one. As we have created two threads, right, for 5. Let's see how it goes then. Now see, even though it is executed 5 threads, but with root, just how many threads are created? Only 1, 2 threads. Okay, like that you can do that. Now this is how we can play around with us. Now if I increase the number of threads to 5, okay, then you are running 5 jobs, then 5 threads will be created, one for one, say 1, 2, 3, 4, 5. That say like that you can have 5 threads. Now in real time scenario, if I saw 100 requests are there but 5 threads, will 5 threads will handle this 100 requests? Yes, definitely. Because how you do that? It maintain a pool of threads, right? 5 threads only will take care of running all these jobs. Let's see this one. You could see how many jobs threads it is running, no matter, but you could see only 5, 4, 3, 2, 1, only 5 threads are there. Even with those some thousands of threads also, even, right, no matter, the available thread pool size only will maintain all these things. But this is also not right way. But this will work if you have only fixed number of threads and your input load is less, and you don't have many requests in your application. But real time scenario, right, that I should utilize all the CPU available process, make it available. How many CPU, what is the CPU capacity and how many available processor available? You have to utilize the button. So how do that? We have a method called runtime, right? There is a runtime dot get runtime. During runtime, it checks the available process, right? If you see there is a method available process, means it returns the number of processors available to the JVM, because JVM is doing this job, right? The value maybe keep changing, that if some other task, some other executor framework, some other executor task in your application consuming some 2 to 3 threads or some number of threads, then how many threads are available here? It returns the current number of threads, which is a return avail threads. Assume it's not a threads, actually these are all processors. Okay, avail count, we can say it is available count. Now this count we can dynamically pass to your pool of threads. So how many threads are available? Then it prints that many. Just print that now. How many threads are default available in our system? Okay, now run this and see now how many threads will be available for us now. 12 threads are there, right? You could see this 12 threads are created, 12 processors are available. So you could see this 12 processor keep running on this one, right? So no matter if you have some thousand, n number of jobs are there, all this available process count will create that. See, good, keep going on, right? But you can't see that it will not create any new threads other than the count available count given count. So this is how the Java executor framework will help us. In going forward, we have n number of methods are there in Java executor framework. Then you can go around those methods, and it also help you to submit the task synchronized. You can perform synchronized asynchronous request also, right? You see that there are two more methods in this, right? Submit and execute. So if you say that submit and execute, these are two methods mainly used. That execute returns void, because you see that now we have execute this method, but what is happening, then we will not expect any return, right? We are not going to expect any return, then we say that execute method gets called. And if any exception thrown from the execution of the task, then execution exception will be thrown directly from the runnable, and it will be hit the thread and cause the current thread to die. So the thread pool will create another thread to replace it. It guaranteed. So what's happened that here, right? If when we are running this thread, if any thread causing an issue, right, the thread will not be alive. The thread will die, and it create a new thread, means it will replace a new thread instead of that dirty thread. So it is just a waste of resources to keep waiting, creating a new thread, right? On the other hand, you see that submit task, right? It returns a object. That object is called a future object, which means it is a container that holds any kind of data. That once you submit the task, then it has to return. It returns something to store that thing. Then future object will be created. But the exception thrown from this task will be wrapped inside the feature, because it is an object. It is holding something that can be a successful result or it can be exception. You only know that get the exception when you call the get method of that, because here in this feature we have one method called get method and prepare to handle it. Hence you should always use submit method, right? Sometimes it is not, then it is not always. I don't say that always use submit method, always use go with, depend on the requirement, you have to use execute method. If you see that if your code does not have any exception or set a simple logic, then you don't expect any return thing, then you go with the execute, and you expect there is a return type. And if you want to handle exception also, if you want to monitor that how it is going, that then you go for the submit task, which is the best approach. Okay, like that you can have a number of methods here and go and play around that one. See this one, all these methods, right? I told you, right? The submit method is that you can call this submit, which returns something, and you can pause. You can call scalable interface and runnable task, anything like that. Just go through this and practice yourself. Then you will get a clear understanding of the Java executor framework. And this is one of the most important topics now using. Nowadays, no one is using the traditional way of using threads, that causing a lot of problems. And here we have more number of methods and flexible options are there using Java executor frameworks. It is very good and thing, right? If you go to the API documentation, you have a lot of things are there. At the beginning level, you just to know what actually the executor framework, how it will help, what is the advantage compared to the traditional threads, how it will help you, what is the main advantage, right? It help you to create a fixed thread pool size, so that the fixed thread pool size will automatically maintain, execute all our submitted tasks. And we have two different types of methods, execute and submit. You can submit any type of things, right? Callable and runnable task here. And we have that another extra features are there which were flexible. So run asynchronously by joining, right? You can merge two different thread result to one single result, like that. Many methods are there. So if you go to this executor framework documentation, they only have the number of examples are there. Okay, that we'll see that in the next upcoming lectures. So this all about Java executor framework and the thread way of working.